Hello friends. So in this next part of the unit 3 of 11th physics NCERT book, that is motion in a straight line, we are now going to discuss the kinematic equations for freely falling body. So here we are discussing motion in a straight line or motion in one dimension, where mostly we have discussed so far the horizontal motion or motion along x-axis. But if an object is thrown upward or if it is falling freely, then it's going to have a vertically up-down motion. So in this is also a motion in a straight line. So what sort of equations can be used to describe or to study the motion in a straight line in a vertical path, that is freely falling body? Now what do you mean by freely falling body? Freely falling body means there is no other force exerted by the object. That means suppose I'm throwing a ball from a height. I'm not exerting any extra force. I'm just losing the ball from my hand and allowing it to fall freely. Now, why did this ball goes down? The ball goes down because there is Earth's gravitational pull which is attracting it. So the ball is now going to fall with the accelerated speed, and the acceleration is given by the g. So we are going to discuss this in the relevant chapter. But the acceleration produced in the object due to Earth's gravitational force is g, and this g is nothing but we know it is 9.8 meter per second square, right? Ignoring air resistance. This is going to be the acceleration, of course, in a downward direction. This is going to be gravitational pull is always towards the earth, that is in the downward direction. So when we study this type of motion, the positive y-axis is up and negative y-axis is downward motion, right? So if the object is allowing to fall freely, then acceleration A is equal to minus g, because the movement is in the negative y direction with the minus g meter per second square, right? So the kinetic equations we are not supposed to derive separately. We already know that for motion in a straight line, v is equal to v0 plus at. So here it becomes v is equal to v0 minus gt, right? So a is now replaced by g, and most of the cases this v0 is also 0. So the equation becomes v is equal to minus gt, right? So this is the slight modification we have to do when we are discussing freely falling bodies. Second equation we have is about distance. So we had written x is equal to v0 t plus 1 half at square. This x, distance traveled x is equal to v0 t plus 1 half at square in a linear, you can say horizontal direction. So in a vertical direction, this, let me say this distance traveled is say y in a vertical dimensions. Then v0 is generally 0, but still for the sake of continuity, let's say v0 t, and g is negative, so minus 1 half gt square. So this can be the formula used. And similarly, we have x is equal to v, you can say 2ax is equal to v square minus v0 square. The similar expression in freely falling body we can have, you can say minus 2ay, to gy rather, a is equal to minus g is equal to v square minus v0 square, right? So these are the another equations. So these are the set of equations which we can use for the freely falling body, right? So please keep in mind, a body is falling freely. It is falling because of the Earth's gravitational force acting on it, and that body does accelerated motion with the acceleration known as g is equal to 9.8 meter per second square, right? So with this background, we'll solve a simple example to understand or consolidate our understanding. Okay, so you can see over here a car moving, sorry, yeah, so this is the example. An object is allowed to fall freely from a cliff. It's a higher place, right? When it travels a distance h, its velocity is v. Hence, in traveling further distance, how much dash? Its velocity will become 2v, right? So the thing is that this object is allowed to fall freely, and in doing so, what is the situation? Initially, when object is at this height with say velocity v0 is equal to 0 because it is allowed to fall freely. Now it has fallen, and after certain distance, say h, the velocity, and let us say that this is the time interval t1, and for that velocity is say v. Now further, how much distance, this is further distance is this much, right? So what is this? You can say h2 is question mark, at which, let us say this is taking certain time, and the velocity at the end is 2v, right? So this is what is to be calculated. So what do we know? We know that g is available as 9.8 meter per second square. So that is known. Now for initial situation, we know v is equal to v0 minus, so v is equal to v0 minus ct, and v0 is 0. So for case 1, this v is nothing but minus gt, so 9.8 into, you can say, t. Let me say this distance is say t1. This time is t1. So this is equation number 1. Now when it is allowed to fall further, so let us say this is the total distance, say x, at the end of which speed is 2v. So once again, for the same formula if we apply, then 2v is also minus 9.8 times, and let us say the total time is t2. So this is going to be t2. Let us say equation number 2. So if I take ratio of equation 2 to 1, so what do we get? v divided by v is equal to minus 9.8 times t2 divided by minus 9.8 times t1, or in short, t2 is equal to 2 times t1. t2 is total time. Please keep in mind, total time to reach the velocity 2v when you start falling freely, right? Now the final velocity and distance is something which we already know. So what is final velocity? Is 2v. We know that you can say minus 2g into y is equal to v square minus v0 square. Now what is final displacement? Let us say it is equal to x. So minus 2 into 9.8 into x is equal to final velocity is how much? 2v square minus 0 square. Is it not? So the distance is already available now. How much is this distance? This distance comes out to be, the formula comes out to be that 4v square is equal to minus 2 into 9.8 into x. You can say this equation number 3. So similarly, for the first case, when the final velocity was v, so when then you have the distance is already h, so minus 2g into h was equal to v square minus v0 square. So v was equal to v only. So minus 2 into 9.8 into h is equal to v square. So this is equation number 4 rather. So if I take ratio of 4 to 1, 4 divided by 3, sorry, if I take ratio of 4 divided by 3, so what do I get? V square divided by 4v square is equal to minus 2 into 9.8 into h divided by, what was the previous one? Yeah, minus 2 into 9.8 into x, right? So v square gets cancelled out. 9.8 to everything gets cancelled out. So what do we know? That x is 4 times h. So the total distance is x, which is 4 times h, and this much distance was h, at the end of which speed v was v, and this is further distance, how much? Obviously 3h, at which the velocity is now 2v. Why? Because the object is falling freely with the 9.8 meter per second square acceleration, right? So obviously the final answer is that further distance is equal to 4h minus h, that is 3h, at the end at which v is equal to, final velocity will be equal to 2 times velocity, right? So this is how we can solve the problems of freely falling object. Yeah. So let's solve one more example and then we'll conclude. So when a ball A is thrown in a vertically upward direction with velocity v0, so a ball is there. This is ball A. It is thrown in upward direction, right? With velocity v0, obviously. So this is having velocity v0, initial velocity. And at the same instant, another ball is allowed to, so this is ball B, which is allowed to fall freely. So obviously when it is allowed to fall freely, its initial velocity is 0. And it is allowed to fall freely from the, this is, let us say this is the ground. And this height is given as h, right? So at any time the velocity of A with respect to velocity of B is, at any time t is this, right? So let us say VA is velocity of A at any time and VB is velocity of B, right? Then both are moving in the opposite direction. So we are supposed to find out nothing but VA minus VB, which is velocity of A with respect to velocity of B, right? So what do we know about VA? VA is V0 minus GT. Time is same, right? So V0 is already given, so this is equation number 1. And what is VB? It is freely up, so it is V0 minus GT. So V0 is 0, so it is only minus GT, right? So this is equation number 2, and this is, say, equation number A. If I substitute the value in equation A, VA minus VB is nothing but V0 minus GT minus of minus GT. So these two gets cancelled out and the final answer is V0, right? So this is the answer. So this is going to be the velocity of ball A with respect to velocity of ball B, right? So this is how we'll be solving more examples based on the freely falling objects. And that's all in this session, where we have discussed the basic equations of kinetic equations of object which is falling freely, and we have also solved a couple of examples to consolidate our learning, right? We'll continue with more such examples in our next sessions. Thank you.